Hello sir, this is Trumal. In this video I am going to explain about hydraulic turbines, session objectives, different types of hydraulic turbines, operation of hydraulic turbines, draft tubes. Introduction. While flowing the water into the turbine, kinetic energy will converted into mechanical energy. Then based on the turbine output, we can produce electricity from the generator. A cubic meter of water can give around 9800 joules of mechanical energy. It will produce 9800 watts of power. The main components of a hydraulic system may be classified into two groups. First one, hydraulic system. Second one is electric system. In this slide, we can see the layout of hydroelectric power plant. History of hydraulic turbines. Turbine was introduced in 1824 by French engineer Bertin. The real turbine was developed in 1827. From that we can produce around 20 to 30 kilowatts. Real turbine was implemented in 1849 and Francis turbine was developed in 1870 and Pelton turbine was developed in 1890 and Kaplan turbine was developed in 1913. Classification of hydraulic turbines. Hydraulic turbines are generally classified as two types. First one, impulse turbine. Second one is reaction turbine. Pelton and Turgot turbine will come under impulse turbine, and Francis, Kaplan and Propeller turbine will come from reaction turbine. Based on the flow direction, also there are further classified as tangential flow, radial flow, or axial flow, and mixed flow. There are three classification based on the direction. Impulse and reaction turbine. The flow energy to the impulse turbine is completely converted to kinetic energy before transformation in the runner. In the reaction turbine, two effects cause the energy transfer from flow to the mechanical energy on the turbine shaft. Firstly, it flow from a drop in pressure from inlet to outlet of the runner. This is denoted as a reaction part of the energy conversion. Secondly, the changes in the direction of the flow velocity vectors through the runner blade channels transfer impulse forces. This is denoted as a impulse part of the energy conversion. The pressure drop from inlet to outlet of the runner is obtained because the runner are completely filled with water. This hydraulic turbine picture. We can see turbo impulse turbine and pump turbine and tubular turbines. Next one, Pelton turbine. This invented by Pelton in 1890. The Pelton turbine is a tangential flow impulse turbine. The Pelton wheel is most efficient in high head application. The largest unit can be produced up to 200 megawatts. Pelton turbine are best suitable for high head and low heights. Less volume of water can generate at same power. So we can generate the more power with using the less water in Pelton turbine. Next one, horizontal arrangement of Pelton turbine. Based on the direction, we can classify it into two types. First one, horizontal arrangement of Pelton turbine, and second one, vertical arrangement of Pelton turbine. There is a difference between from these two. In horizontal arrangement of Pelton turbine, we will fix the turbine horizontal direction. In vertical arrangement of Pelton turbine, we will fix the turbine direction in vertical. Parts of a Pelton turbine we can see in this slide. And turbo impulse turbine. Turbo impulse turbine design was developed by Gilkes in 1990. The turbo turbine is a impulse water turbine designed by designed for medium head application. For medium head application, we can choose turbo impulse turbine. Turbo runner may have efficiency more than 90%. This slide we can see the parts of turbo impulse turbine. Next one, Francis turbine. From this we can produce around 750 megawatts during the operation. The Francis turbine, another name is reaction turbine. This turbine head range from 20 to 750 meter. Francis turbine also we can classify it into two types based on the direction. First one, horizontal shaft Francis turbine, and second one is vertical shaft Francis turbine. Both the turbine image we can see in these two slides. Next one, regulating mechanism for Francis turbine. The guide vane mechanism along with the governors provide the regulation of the turbine output. Next one, propeller turbine. The propeller turbine have the following favorable characteristic: relatively small dimension combined with high rotational speed, the favorable efficiency curve, and third one, a large overload capacity. Next one, Kaplan turbine. Kaplan turbine we can see in this image. The Kaplan turbine is a propeller type water turbine that the adjustable blade. It was developed in 1913 by the Austrian professor Victor Kaplan. The Kaplan turbine was an evolution of the Francis turbine. It allowed efficient power production in a low head application that was not possible with Francis turbine. Whenever we can, so for low head application we can choose Kaplan turbine, which is not possible from Francis turbine. Power plant with net head range from 10 to 70 meter. Tubular or bulb turbine. Tubular turbine is a reaction turbine of Kaplan type which is used for the lowest rate. In a bulb turbine, the water flow with a mixed axial radial direction into the guide vane. The guide vane spindle are inclined normally 60° in relation to the turbine shaft. Next one, parts of a bulb turbine. First one, bulb nose, access arm, removable cover, oil distribution head, generator, upper stay vane, upstream thrust and counter thrust bearing, lower stay vane, downstream bearing, adjustable distributor, blade and turbine pit. In next slide we can see impulse turbine head. What is meant by class head? It is the difference between the head trace and the tail trace level when there is no flow. As such, it is termed as static head and denoted as HS or HG. Next one, reaction turbine head. Reaction turbine head we can see in this slide. Next, velocity triangle for Kaplan turbine. Next one, types of draft tubes. There are four type of draft tubes we are using in turbines. First one, conical type, elbow, hydrocone, and Modi spreading type. Efficiencies of hydraulic turbines. There are four various efficiencies of hydraulic turbines. their hydraulic efficiency and volumetric efficiency, mechanical efficiency, overall efficiency. In this slide, we can see efficiency versus load for turbines. First one, Impulse, Francis, Propeller, and Kaplan. When a designer is going to design the turbines, they will consider the head and specific speed before selecting the turbines. In this slide, we can see the head and specific speed ratio according to the turbine types. For Pelton wheel turbine, head range is greater than 300 meter and speed 8.5 to 30. For single jet, 30 to 51, 2 or more jet. Francis turbine head is 50 to 450 meter, specific speed 51 to 255. Kaplan turbine head is up to 60 meter and specific speed 255 to 860. Thank you.